Good morning students. Today we are here to discuss lines and angles. Let's get started. So this is our line. Okay. So the arrows here shows that it does not have a fixed length. We can extend line from both the ends, right? We generally use small letters to represent a line. So let's say this is line M. Now I am going to show you line segment. The end dots represent here that a line segment has endpoints and it has finite length. Okay, let's say it has 6 centimeter as its length and I'll call it line segment AB. Now we are having ray. So this arrow shows that it can be extended from this end, but this dot shows that this is the end, right? We cannot extend it from here. So this is our ray. Let's name it PQ ray. Okay. So the representation for this will be PQ ray and AB line segment will be this, and for the line M, let's call it line ZY. So the line ZY can be represented like this. So these are the representation. This is our line, it has no endpoints. This is our line segment, it has endpoints, and this is our ray, it has only one endpoint. Right. So now we will discuss angle in detail. Okay. Suppose I have one ray like this and another ray like this. Let's name them OA and this is our B. So I have one ray that is OA and another ray that is OB. So what we have between these rays is nothing but our angle. So this is our angle, and angle is generally represented by theta. So what we have done, in other words, we can also say that the amount of rotation which we have to take to reach OB from OA. So what we have done, we have moved this much. Okay, we have started moving from this point and we have reached here, right? So this is our angle and it is represented by theta. Basically we measure angle in degree, but we also have some subunits like minutes and seconds. We should keep in mind that 1 degree is equal to 60 minutes. This single dash represent the minute, okay? And 1 minute is equal to 60 second. These double dots represent here seconds. So sometimes we have to use this, otherwise the unit for the angle is degree. Suppose this angle is 60 and we can measure the angle by using the protractor, right? So this is our 60-degree angle. Now we will discuss the types of angles we have on the basis of its measure. So I'm going to erase this, then we will discuss the types of angles. Yes. Suppose I have angle like this. Okay. You can clearly see this angle is less than 90 degree. How can we say that? Let me draw this for you. When two lines are perpendicular, only then the angle will be 90 degree, and we can clearly say this line is not perpendicular to this, right? This ray is not perpendicular to this ray. So this angle is going to be less than 90 degree, but it is greater than 0 degree, right? Now the question should arise, how can an angle be 0 degree? It can happen. Let me explain it to you. This is our ray 1, okay? This is our ray 2. It is coinciding. So the angle will be 0 degree here, right? We do not have to move to reach our final terminal arm. Let me explain you the term, what is terminal arm and what is initial arm. See, if I have made angle like this and I have to move from this ray to this, and we have made angle theta is equal to 30 degree. Let's say it is 30 degree, okay? So this is our initial arm. Since we have started from here, so this becomes our initial arm, and we reached here, right? So this is become our terminal arm. Terminal arm, and the point from where the two rays are originating will be called as vertex. So I hope we are clear with the term initial arm, terminal arm, and what is vertex, right? So here in 0 degree, we can clearly see the terminal arm and the initial arm are coinciding. So the angle is here 0 degree. So this angle is greater than 0 degree, right? But it is less than 90 degree. So when angle lies between 0 degree to 90 degree, it can be called as, it will be called as acute angle. Okay. What if I move this terminal arm from here to here? Okay, I have moved this terminal arm from here to here. Now it is making 90 degree, right? Now it is making 90 degree. So when the theta is equal to 90 degree, right? When theta becomes 90 degree, we call it as right angle. So this angle is a right angle. You might have heard about right angle in the Pythagoras theorem as well, right? Now, how about I move this terminal arm further? Now, I am going to move this terminal arm further like this. And I am erasing this one. So, what I have done? Till here we have 90 degree and we have to move little more. So this angle is going to be more than 90 degree. It is clear? This angle is going to be more than 90 degree. But this is less than 180 degree. Now here one question should also arise. What is at 180 degree angle? This is straight line is making 180 degree angle from here. Since when two rays lies on the same straight line, then the rays make angle 180 degree. Okay, so this is our 180 degree. So we can take reference from here. This angle is more than 90 degree, but it is less than 180 degree, because here it is making 180 degree, but till here it is not making 180 degree, but it is more than 90 degree. So what we can say, when an angle is more than 90 degree but less than 180 degree, it will be called as obtuse angle. This is our obtuse angle, and we are clear with the straight angle. Okay, now I am going to summarize all types of angles in a Cartesian plane. Suppose this is our Cartesian plane. Okay, this is our 0 degree, this is our 90 degree, this is our 180 degree, and this is our 270 degree, right? This is our positive x-axis, negative x-axis, positive y-axis, negative y-axis. Okay, suppose an angle is formed in this region with the ray OA, and this is our row OB. Okay, so any angle which is formed from here to here, like in this region, will be called as acute. Why? Because it will lie between 0 to 90 degree only. So in this region we can say this region is for acute angle. And when theta becomes equal, theta will be equal to 90 degree, it will be our right angle. Now in this region, if theta lies in this region, that is between 90 to 180, it will be like this. If this is our terminal and this is our final initial arm, so theta will be like this. Okay, so this will be our obtuse angle. Anywhere in this region, all the angles will be obtuse angle, anywhere, right? This is our obtuse angle. All the angles which are formed in this region will be our obtuse angle. Why? Because they are more than 90 degree but less than 180 degree. So this will be our obtuse. Right? What about this angle? We have started from here and end here. So you can clearly see ray OA, and let's call it P. Ray OP lies on the same straight line, right? So the angle will be 180 degree here. Okay. Now, what if I draw another ray here? And what we have to do, I am erasing so that you will not get confused about the angles. We already have done so many angles here, right? Give me 1 minute. So this is our positive Y. Okay. So this is our initial arm, this is our terminal arm. We have moved so far. Okay. So this angle is known as reflex angle. So you can clearly say that the reflex angle is greater than 180 degree. Now, if I make another terminal arm here, and this is the angle which the terminal arm make with the initial arm. So, this angle will be also called as reflex angle. Okay. So, what we can infer from here, the reflex angle is greater than 180 degree but less than 360 degree. Now, the question should arise, what is 360 degree angle? And we can also call it, as complete angle. Okay, 360, when theta is equal to 360 degree, we call is a complete angle. So when theta becomes equal to 360 degree, okay, let me tell you. See, this is our initial arm and our final arm. See, I have started moving here. So the terminal arms takes one complete rotation, right? When your terminal arm takes one complete rotation, and we just end it here, right? From where we have started, we end there only. So then theta becomes is equal to 360 degree. Okay. So there must be confusion between 0 degree and 360 degree because they look same. But what is the difference? Here the terminal arms and the initial arms lies here only. We haven't moved anywhere. But in the 360 degree we have taken one complete rotation. Okay. So this is the basic difference. So I hope we are clear with the types of angles we have. Okay. Thank you class for today.